So today we are going to study difference between integration and differentiation. These two are in my hands. Yeah, this is integration, this is differentiation. So actually these both processes are inverse of each other. So we will explain in this video what is the difference and the major difference between that is differentiation and integration of a function. Okay, so first of all the question comes in our mind that what is function? So function is what? When you say y equal to f of x, what is f? F is the rule applied on x such that we get the values of y. If I take a sin x, y equal to sin x, sin is f of s, sin as acting as a rule applied on x such that we get the values of y. If we apply sine, then we get a oscillating curve. If I apply another rule, that is square, y equal to x square will have a parabolic shape. So as we are changing the particular rule on x, we are getting different values of y, and it is actually creating a curve. So actually function is understand as that it is a rule applied on x such that we get the values of y. Okay, now the major topic, that is differentiation and integration. First we will understand what is differentiation. Okay, so differentiation is what? In practically, if you want to study anything, then we have to if we want to have a better understanding of anything, so we have to study that thing at very minute level. For example, if we are studying a body, we have to analyze it at the level of cell. If we want to uh, anything that is in chemistry, if we want to analyze any substance, then we have to go to the atom level, nucleus level. In the same way, if we have to have a better understanding of function, then we have to be at a very minute level, and this does differentiation. Differentiation is actually the study of the functions at a very minute level to get a better understanding how our function is behaving. So by differentiation we get to know how our function behaves and how the curves behaves. So the main part differentiation is denoted by, you know, that dy by dx, that is equal to delta y upon delta x, and that is equal to y2 minus y1 upon x2 minus x1. The x is in our hand, that is independent variable, and y is the dependent variable. So it simply means when you are changing a value of x, how the values of y is changing, that is only differentiation. So what are the application of derivative? So the major application of derivative is rate of change of derivative, increasing decreasing function, tangent and normal, maxima and minima, and many more. So first of all we will talk about the rate of change of derivative. So what is rate of change of derivative? That simply means what is the change in the value of y when you are changing x. So for this I will take a beautiful example. There is a town whose population is 1 lakh in 2000 year. After 5 years, that is in 2005, the population of the town is 5 lakhs. After 5 years again in 2010, the town population is 9 years. So from this we get to know the behavior of the population, right? For every span of time of 5 years, the population is increasing at the rate of 4 lakhs, right? After 5 years again there is a 4 lakh increment. So from this we can say that for delta x there is a delta y. Delta x is 5 years and delta y is 4 lakhs. So if anybody asks me that what is the population in 2090 or something, then I can simply answer it. So but here the accuracy will be not very good. But if I will reduce the time span, suppose I get to know that after 1 month what is the population of the town, then my result will be more accurate. If I will reduce further, that is for 1 hour, then our result will be more accurate. If for 1 minute, the result will be most accurate. For 1 second, it will be other more, right? So from this we can say that if we the delta x is in our hand, right? If we control delta x to very small value, our result will be a better. For by this only I am saying that so differentiation is the study of the function at a very minute level. So you can say that by study of differentiation, we simply get to know a better behavior of our curve. So we can get the more accurate results at different points and also the behavior of the curve. Now what is integration? So integration is simply means antiderivative. It is just the inverse process of differentiation. If for a function, if I apply differential operators and integration operators, this both will cancel out and the function will remain as it is. So you can see that it is simply like a inverse functions. Okay, so integration sign is like s. That simply means summation. So how it is a reverse process of differentiation, let's understand this topic. So in integration, what we do, I will show you by one example. If I take a simple shape rectangular, a regular shape rectangle, so if its length is L and breadth is B, so what is the area? Length into breadth, simply. But if the uh, length will be, that is the upper one is irregular shape. Suppose that is a curve, right? Okay, it's very irregular. Okay, it is not a regular shape. Okay, and that upper curve is denoted by y equal to f of x. Then how you are going to find the entire area? That is the area under curve. That is the major application of integration. So what we will do, we will divide this whole body into very small strips. So the one strip will look like what? One strip will be look like, this is whole x, right? And we were dividing, so this is delta x, that is dx. Okay, for this x we will get a height, that will be f of x. So this is height and this is what? This is the length. So length into breadth or height, so that will give our area. So that is f of x into dx. So f of x into dx will be the area of that particular strip. Now if I sum up all these strip fx into dx, I will take a integration operator on this. So by that means that every strip is added. If I add every strips, simply we get the integration of that sum, and that is equal to area of the curve.